Hi, folks. We're going to take a look at page 350, number 19, and another question that was set for homework, which had to do with the relationship between the areas of two similar triangles. So what it asks you to do is to take two triangles with a factor of k between them. So if I have, say, triangle A, B, C, and then I have a similar triangle whose factor between the corresponding sides is equal to k. So instead of calling this, say, capital A, capital B, capital C, since I know the relationship between them, I'm going to call this k times A, k times B, k times C. All right, so similar triangles, meaning they have the same angles. But if I want to determine some relationship between the areas, well, I can use C and KC as the bases, but what I need is I need the height of these, or the heights of these triangles, in order to talk about the area. Okay, so let's see if we can figure out a relationship between the two heights. So let's say we call this smaller one H. Well, this is where I want you to look at now this right angled triangle that I've created on the left in this small triangle and this right angled triangle here. Well, these two angles are the same, all right? And of course, they're both right angled triangles. So in other words, these right angled triangles that I've just created are also similar. Okay, and so that means that if this length in that triangle is A and this is KA, means the factor between them is K. So that means we can now say that this height is going to be K times H, that the height has the same factor as the other three sides. Okay, and this is because I was able to create similar right angled triangles in both of the triangles. So now, if I want to compare the area of the larger triangle to the area of the smaller triangle, so let me find the ratio of those two. Well, let's start with the area of the larger triangle is going to be base times height divided by 2. So base is KC times the height is KH divided by 2. And then I'll divide that by the area of the smaller triangle, which is going to be the base, which is C, times the height, which is H, divided by 2. And now let's simplify this expression, okay? So remember that dividing fractions is the same as multiplying the reciprocal of the denominator, okay? And while I'm rewriting this here, well, I can write this in any order since it's a whole bunch of multiplications in that numerator. So I'm going to bring these k's together and write it as k squared. And here, I'm going to keep the c and the h together, divided by 2. So times the reciprocal of this here, which is going to be 2 over ch. And here we've got a lot of nice things that goes on because the 2 in the numerator reduces with the 2 in the denominator. The c and the h in the numerator here reduces with the ch in the denominator there. And the only thing I'm left with is k squared. All right. And this gives us one of the another property of similar triangles is if the factor between corresponding sides is k, then the ratio of the areas is k squared. All right. And so now this is what we're going to use to solve question 19 here. So let's take a look at question 19. So we have that the areas of two similar triangles are, just got to move that around. The areas of two similar triangles are 72 and 162 centimeters squared. What is the ratio of the lengths of their corresponding sides? So in essence, we're going to be going backwards here. All right. So what we have is we've got, say we call, triangle, the area of triangle 1 is equal to 72, or even we'll use what we had before. The small one is 72 centimeters squared. The area of the larger one is, what was that? It was 162 centimeters squared, and they want us to find the ratio of the lengths of the corresponding sides, in other words, the factor between them. So here, since they gave me the smaller one first, I'll go in that direction. Okay, so if I want to determine what k is, in other words, what the factor, okay, let's just look at the ratio of the areas. So the ratio of the areas is AS over AL, which is equal to 72 over 162. And this we know is going to be equal to k squared. So whatever the factor is between the corresponding sides, we know the relationships, the ratio of the areas is k squared. So before I try to take square root on both sides here, because I'm not going to necessarily end up with something nice, I notice that if I simplify this fraction here, well, I notice that, hey, they're both divisible by 2, and 72 divided by 2 is 36, and 36 is very nice because it's a perfect square, okay? And here, 162 divided by 2 is 81, another perfect square. Now, they have other factors in common, except, they also have 3 in common. But if I divide 36 by 3, 81 by 3, I'm not going to end up with perfect squares. So I'm going to leave my fraction as is. So now, in order to solve for k, I just have to take the square root of 36 over 81. Okay, now notice here, I'm not taking the positive and negative square root because I'm just determining a factor between two lengths. So it doesn't make sense to find a negative factor between lengths. So here, k is just equal to, well, what's the square root of 36? Is 6. What's the square root of 81? That's 9. So k is equal to, we can simplify this now, 2 over 3. So if the ratio of the areas, which we know is supposed to be equal to the square of the factor of the side lengths, is equal to 72 over 162, that means the ratio of the side lengths is going to be 2 over 3. Okay, that's it for this one.